Well, good morning, good afternoon, and good evening. I've got the great pleasure to be speaking with Professor Bronwyn Fox, Deputy Vice-Chancellor of Research and Enterprise at Swinburne University in Australia, where it is morning. I've got Steve Rodgers, founder and CTO of Emergentek in the USA, where it is the afternoon. And my name is Rob Whieldon. I'm the Operations Director at Nixene Publishing in the UK, where it is evening. So welcome. I wondered if, by way of sort of background, Bronwyn, I wondered if I could ask you a little bit about how you got involved in the graphene field.
Really lovely to speak with you this morning, Rob and Steve. And I've always been fascinated by carbon. I think since I lectured first year materials really early on in my PhD, where we looked at structure property relationships with carbon. And to me, it was just fascinating that just by changing the bonding and the arrangement of the atoms, you could achieve completely different properties, that you could go from the hardest material known to man, diamond, to a solid lubricant, graphite. And that really piqued my interest in carbon. At that point, I was working with carbon fibre composites and working with carbon in a fibrous form. And then, of course, later became interested in carbon nanotubes. And I was actually doing a sabbatical in Manchester as graphene was being discovered, which was an epic fail in my career because I was working in a completely different group and on a different topic. But it was wonderful to be in the home of graphene and as it was being discovered and really explored.
Part of the reason we're talking today is that you're presenting at the SAMPI Graphene Leadership Conference on the 11th of November. Perhaps you could just say a little bit about the background to your presentation without giving any spoilers away.
Okay, well, we've been working on graphene for a while, both in my time at Deakin University and now at Swinburne, and I'm really interested in the industrialisation and industrial applications of graphene. In my former role at my former university, we had a project with industry to explore the use of nanomaterials as a strengthening additive for polyethylene nanocomposites. And that work was really interesting. The project went for almost 2 years and we looked at every nanoparticle that you could imagine. We explored nanoclays, carbon nanotubes. We really tried everything and nothing improved the properties of polyethylene. And then right at the last minute before the project ended, one of our brilliant researchers, Manu Navy, came up with the idea of trying graphene, and it improved the properties of that polyethylene. It was a 30-fold improvement in some properties, and that has been commercialised and now is being used to manufacture pipes by a company called Qenos, and it's really given them the ability to make much thinner walled pipes with higher performance, higher burst pressure. And that was my first foray into graphene, and it was a really fascinating experience that really highlighted a number of issues. One of them was that when we discovered that that grade of graphene worked so well for that product, we thought, right, of course, let's try some other grades of graphene and maybe we'll get an even better result. And none of the other grades that we tried worked anywhere near as well or improved the properties at all. So that really highlighted to me the importance of understanding structure-property relationships in graphene and how critical that was for the company as they were trying to commercialise the technology. If they went to their management and their board and said, we have this incredible product, but we can only make it with one supplier and one grade from one supplier, then that's a really high risk. And the company, their board was very reluctant to invest in it and to commercialise it. It was only when we started to really unpack why that grade of graphene worked better than others that the investment flowed. And it was from that work that we established with a company called Imagine Intelligent Materials, who are based here in Australia, a framework for really understanding the structure property, structure performance relationship of different graphene grades, comparing and contrasting them, and then we were working towards, and we have a framework now for a graphene quality index that we hope will give companies who are on that journey of commercializing graphene technology confidence that they have security of supply, and that if one of their suppliers goes out of business or something happens and they can't produce that grade, that they can then go to an alternative supplier.
That's very interesting, because one of the points that I emphasize more than once in my tutorial is the fact that all graphenes are not created equal, and that seemingly insignificant difference in the nanoscale can translate into huge performance differences in the Newtonian scale.
I couldn't agree with you more. And I've been collaborating with a computational nanoscientist who has a data set with 60,000 different graphene oxide structures. And she's getting incredible insight into what's important from her data set using machine learning to understand the relationships between different structural features and the property of that particular graphene structure. So I think the experimental approach that where I sit, and probably where you sit, Steve, is really important, but it can be augmented by computational techniques as well, and it's really important to make that link. One of my industry partners actually said to me a number of years ago, graphene can do anything apart from escape the laboratory. And I think we're seeing an incredible time where graphene is escaping the laboratory. And on this call, we have representatives from the UK and the US, and I'd love to hear more about where you see that we could work together as a global community to ensure the translation of new graphene technologies into commercial applications, and where the markets will be. I'd love to hear both of your thoughts on that.
I think one of the areas that I'm very interested in is your qualification process. I think that one of the big challenges that we have in the industry in terms of commercialization, getting things out of the laboratory, is really the ability to quickly analyze material and ensure lot-to-lot, batch-to-batch consistency of product. The fact that so much variability exists within the community, it's going to be really important to tie that down. I remember talking with somebody from Haydale who told me that in the beginning they experimented with 250 different graphenes, and that all of them were different somehow, and that only 12 were usable by them. We need to get to where we can characterize things and understand the morphology much more quickly than we do at this current time.
Well, I would say this from a publishing company, but I really strongly believe it's knowing what everybody's doing, so we can share the knowledge and the information, and not the hype. Because often you see in the press the hype around graphene, and you could argue it's companies trying to bump up their share price or whatever. And actually what we really need to know is who's doing what, not necessarily giving people's secrets away, but knowing who's doing what, working in what fields and what areas. And that opens the door for sharing, for understanding, for everybody to help each other out. Well, thank you so much, Bronwyn. It's been really fascinating being able to speak to you this afternoon or this evening or even this morning. And I'm really looking forward to hearing your presentation on the 11th of November at the SAMPI Graphene Leadership Summit. And thank you, Steve, for hosting this sort of conversation and hosting the SAMPI Summit. So I look forward to seeing you there. Thank you.